Your Toyota is secretly burning through fuel right now, and you have absolutely no idea it is happening. There are features built into your vehicle straight from the factory that are actively working against your fuel economy every single time you turn the key or push the start button. Some of them sound helpful on paper. Some of them you have probably never even heard of, and at least 3 of them you were likely using every single day without realizing they are costing you an extra $400 to $800 a year at the pump. I've been working on Toyotas as a master technician for over 15 years, from older Entune systems to the newest audio multimedia touchscreens and Toyota Safety Sense suites. I have lost count of how many times an owner has come into the shop complaining about getting terrible gas mileage, only for me to hook up the scanner, dive into their settings, and find 4 or 5 factory defaults that are the direct cause of the problem. Toyota engineers these features to pass strict EPA emissions tests, hit federal CAFE fuel economy targets on paper, and check off boxes for showroom marketing materials. They are engineered for compliance. They are not always engineered with your real-world fuel bill in mind. Today we're going through 10 stupid Toyota features that are killing your gas mileage, what they are actually doing under the hood to your engine and electrical system, and exactly how to turn them off or dial them back. Number 7 is one that most Toyota owners will actively defend until they actually see the diagnostic data. And number 1 is so blatantly obvious once you hear the mechanical logic that you will be furious nobody told you the day you drove off the dealer lot. Let's get straight into it. Feature number 10, trailer sway control left active unloaded. This one sounds completely absurd, but stay with me mechanically. Trailer sway control is integrated into Toyota's Vehicle Stability Control (VSC) architecture. On most Tundras, Tacomas, 4Runners, Sequoias, and even Highlander models equipped with factory tow packages, this system remains partially active in the background, even when there is no trailer hooked up to your receiver. Here's what happens under the body. The ECM continuously monitors lateral yaw sensors and steering wheel angle input. When you're cruising down the highway at 65 miles per hour, the system is actively looking for trailer-induced oscillation. When driving solo, it frequently interprets normal lane adjustments, highway expansion joints, or strong crosswinds as potential trailer sway events. To counteract what it thinks is an unstable load, the ECM initiates micro-braking corrections on individual wheels and momentarily pulls back throttle intervention. You barely feel it in the seat of your pants, but your engine control module registers it, and your fuel economy absolutely suffers. The fix is straightforward. Using your steering wheel controls, navigate through your multi-information display, the MID screen right between your gauges. Go to Settings, scroll to Vehicle Settings, locate Trailer Sway Control or Towing Assistance, and toggle it to Off, or set it to Towing Only if your specific model year provides that menu option. You won't feel a massive performance surge on a single trip, but Toyota owners who toggle this off while driving unloaded consistently report gaining between 0.3 and 0.6 miles per gallon on highway stints. Over 15,000 miles a year, that adds up faster than you think. Feature number 9, automatic high beams. Automatic high beams are part of the Toyota Safety Sense suite that Toyota started standardizing across almost its entire vehicle lineup around 2018. A camera mounted behind the windshield near the rearview mirror detects ambient light and oncoming headlights, automatically switching your high beams on and off. Sounds like a great convenience feature in theory. In practice, the system is hypersensitive and frequently leaves high beams engaged in scenarios where you do not need them, like well-lit suburban streets or highways with distant reflective road signs that confuse the optical sensor. Here is the mechanical connection to your fuel tank that most drivers completely overlook. High beams draw significantly more wattage than low beams. On halogen headlight systems common in older or base-trim Toyotas, high beams draw around 55 to 60 watts per bulb, compared to 35 to 40 watts for low beams. Even on LED-equipped Toyotas, running high beam arrays alongside accent lights continuously places a sustained electrical load on the vehicle's 12-volt charging system. Your alternator is not a free energy machine. When electrical demand spikes, the alternator's magnetic field tightens, creating physical mechanical resistance against the engine's serpentine belt drive. The engine control module has to feed slightly more fuel to maintain base idle and cruising speed against that parasitic load. Turn automatic high beams off by pressing the AHB button on the lower left dash panel or switching the headlight stock to standard manual control. Use your high beams intentionally when visibility actually demands it, and stop forcing your alternator to pull extra horsepower from your engine when it isn't necessary. Feature number 8, lane tracing assist set to maximum intervention. Toyota's lane tracing assist uses the forward-facing camera to track lane markings and actively applies torque to the electric power steering motor to keep the vehicle dead center in the lane. When left on its highest sensitivity setting, the system is in a non-stop fight with the road, and often with you. At maximum intervention, the system makes continuous micro-adjustments to the steering rack. Every single time that electric steering motor fires up to nudge the vehicle millimeter by millimeter, two things happen. First, the EPS motor draws a high current spike directly from the electrical system, forcing the alternator to step in. Second, these constant micro-corrections force the front tires to scrub against the asphalt at microscopic angles, creating unnecessary rolling resistance. Furthermore, because the system is constantly fighting your natural micro-steering habits, drivers unconsciously apply counter-pressure to the wheel. That tug of war between driver and motor destabilizes smooth momentum. Go into your MID settings under LTA, Lane Tracing Assist, adjust the steering assist function from high down to low, or switch it to alert only. You will still get a visual or audible warning if your vehicle wanders toward the fog line, but you eliminate the aggressive steering motor drag and tire scrub that subtly drains your fuel tank over long highway stretches. Feature number 7, running AC with Eco Heat Cool mode disabled. This is the exact feature Toyota owners will argue about in the comments section until I pull up the live data stream on a scan tool. The air conditioning compressor is one of the single largest parasitic mechanical draws attached to your internal combustion engine. On modern Toyotas, such as a 3.5-liter V6 Highlander, a 2.5-liter Dynamic Force RAV4, or a 3.4-liter twin-turbo Tundra, the AC compressor is a variable displacement unit. When operating at maximum engagement, that compressor can sap anywhere from 8 to 12 horsepower directly from the crankshaft. That is pure mechanical energy being used solely to compress refrigerant rather than sending power to the drive wheels. Toyota equips almost all modern models with an Eco Heat Cool function, either via a physical button on the climate stack or embedded inside the climate touchscreen settings. Many owners turn this off because they assume it drastically degrades cabin cooling. That assumption is incorrect. Eco Climate Mode does not shut off your air conditioner. What it actually does is instruct the climate ECU to manage the compressor's swash plate angle more intelligently, cycling the displacement down during acceleration load spikes, and leveraging blower fan speed control to maintain cabin comfort. Testing across multiple Toyota platforms shows a consistent improvement of 0.5 to 1.2 miles per gallon during summer driving when Eco Climate Mode is left active. Turn it on, leave it on, and stop letting your AC compressor leach unnecessary horsepower from your engine. Number 6. Toyota Remote Connect Maximum Preconditioning Time. Remote start through the Toyota app or key fob is a fantastic comfort feature on freezing winter mornings or blistering summer afternoons. Nobody's telling you to stop using it entirely. However, the vast majority of owners have never checked how long their vehicle is programmed to idle before they actually step inside and put their foot on the brake. Out of the factory, many Toyota models default to a 15-minute idle cycle per remote start request. Idling a cold Toyota engine, whether it's a 4.0-liter V6 4Runner or a 2.4-liter Turbo Tacoma, burns through fuel at a terrible rate. A modern Toyota engine running 0W16 or 0W20 synthetic oil reaches full oil pressure within seconds in safe operating temperatures in under 2 minutes of gentle driving. Go into your Toyota app or vehicle system preferences and reduce the remote start runtime limit down to 5 or 7 minutes. Your cabin will still reach a comfortable temperature, but you will stop burning dollar bills through your exhaust pipe while sitting in your kitchen. Number 5. Misusing dynamic radar cruise control in heavy city traffic.
Toyota's millimeter wave radar and windshield camera combo do an outstanding job of maintaining distance from the vehicle ahead on open highways. But using full-speed range DRCC in heavy stop-and-go city congestion is a massive fuel economy killer. Here is why. The radar sensor is programmed to maintain a specific vehicle gap distance at all costs. When the car in front of you accelerates away from a stoplight, DRCC does not gently ease into the throttle to conserve fuel. It reads an opening gap and commands a heavy throttle application to match speed rapidly. Then, when that same car hits its brakes 200 feet later, the radar panics, cuts throttle sharply, and slams on the brakes. This endless cycle of aggressive throttle spikes followed by heavy friction braking completely eliminates your vehicle's kinetic momentum. You burn extra fuel to accelerate hard, only to instantly convert that burned energy into wasted brake heat seconds later. In congested stop-and-go traffic, turn cruise control off completely. Manage the throttle manually. Anticipate traffic flow far ahead and roll smoothly through slow points. Save dynamic radar cruise control for open, steady-speed highway cruising where it actually operates within its maximum efficiency window.
Feature number 4, driving with traction control, track/VSC in aggressive profiles on dry pavement. Traction control is a non-negotiable safety feature on rain-slicked roads, mud, ice, and snow, but on dry, high-traction asphalt, aggressive electronic traction management often acts as an artificial tax on your engine's efficiency. Toyota's track system operates by continuously comparing wheel speed sensor data across all 4 hubs. When you pull out of a parking lot onto a busy street, turn sharply, or accelerate uphill on dry pavement, the system can detect subtle variations in wheel speed caused by body roll or suspension flex. It interprets those normal speed variations as loss of traction. The ECM instantly reacts by retarding ignition timing, closing the electronic throttle plate, and selectively pulsing the ABS brake actuators. What happens next? The vehicle bogs down momentarily because the system stripped power out from under your foot. To compensate for that sudden hesitation, you naturally press the gas pedal down further. The ECM then responds with a heavy fuel enrichment command once the traction restriction clears. You just burned twice as much fuel to achieve the exact same rate of acceleration. On dry pavement, ensure your vehicle is in normal or sport mode rather than an aggressive eco-throttle curve that triggers delayed power delivery. Or press the track control button once on performance/truck models to enter a relaxed slip profile while keeping full stability control active. A smooth, uninterrupted acceleration curve will always burn less fuel than a jerky, computer-throttled one. Feature number 3, non-hybrid auto stop and start systems. Now, let's clarify immediately, we are not talking about Toyota's legendary hybrid synergy drive systems in cars like the Prius or RAV4 Hybrid, which use high-voltage traction batteries and heavy-duty motor generators designed specifically for seamless engine shutoffs. We are talking about the conventional 12-volt stop and start systems fitted to non-hybrid gas models, like standard Highlanders, Tacomas, and older Camrys. Federal testing cycles show that auto stop and start saves fuel during long, motionless pauses, but real-world urban gridlock is not an EPA test bench. In heavy stop-and-go driving, where you stop, move 10 feet, and stop again every 20 seconds, the system actually works against your efficiency. Every time the engine shuts off, the 12-volt starter motor draws a massive current spike from the battery to restart the engine seconds later. To recover that lost electrical energy, the ECM commands the alternator to charge at maximum output the moment the engine fires up. That maximum alternator load places heavy mechanical drag back onto the engine. Furthermore, every single cold restart forces the engine control module to run a momentary rich fuel startup sequence to stabilize combustion. In heavy, rapid stop-and-go conditions, those constant startup enrichment spikes and high alternator charge cycles consume more fuel than the engine would have burned, simply idling smoothly for those brief 15 seconds. Press the Auto Stop and Start Disable button,
A off on your console when driving through dense, slow-moving city traffic, or install a plug-and-play stop-start eliminator module to bypass the default memory setting permanently. Save the system for scenarios where you were sitting at long, predictable light cycles. If you are getting real value out of this mechanical breakdown, go ahead and hit that like button and subscribe to the channel right now. We are about to cover the top 2 absolute biggest fuel economy killers on this entire list, including one hidden tire pressure myth that tricks thousands of Toyota drivers, and an Octane secret that Toyota dealerships will almost never explain to you at the sales desk. Hit that subscribe button and let's dive into the top 2.
Feature number 2. TPMS warning light ignorance and 5 psi drop myth. This is not a feature you turn off. It is a factory monitoring system that most Toyota owners drastically misunderstand to the detriment of their wallet. By federal law, your Toyota's TPMS system is calibrated to trigger a low-pressure warning light on your dash only when a tire drops 25% below the factory-recommended door jam specification. Think about what that actually means mechanically. If your Toyota RAV4 or Tacoma calls for 35 psi in the tires, your TPMS dashboard light will not illuminate until that tire drops down to roughly 26 psi. Driving on a tire at 26 psi increases its rolling resistance by as much as 15 to 20%. The tire's sidewall flexes excessively, generating extreme heat and forcing your engine to work significantly harder just to push the vehicle forward at highway speeds. That can easily cost you 1 to 2 miles per gallon. Here is the kicker. Your tires do not need to be 25% low to destroy your fuel economy. A tire that is just 4 or 5 psi underinflated will show a measurable increase in rolling resistance, yet your dashboard light will stay completely dark. The computer thinks everything is fine, while your gas tank is draining faster on every commute. Do not wait for a dashboard warning light. Buy a high-quality $15 digital tire gauge, check your tire pressures manually once a month when the tires are cold, and inflate them strictly to the door jam placard inside your driver's door pillar, not the maximum pressure molded onto the tire sidewall. This is the single cheapest, easiest fix on this list, and it works every single time.
Feature number 1. Running regular 87 octane in turbocharged and high-compression Toyota engines. This is the absolute single biggest fuel economy mistake Toyota owners are making today, especially with Toyota's massive shift toward forced induction powertrains. Toyota heavily markets their new engine lineups, like the 2.4-liter turbo I-Force in the Tacoma and Land Cruiser, the 3.4-liter twin-turbo V6 in the Tundra and Sequoia, and even the 2.5-liter dynamic force high-compression engines as capable of running on regular 87 octane. Technically, that statement is true. The engine will not blow up on 87 octane. But what the dealership salesperson never explains is how the engine survives on 87 octane. Modern Toyota engines run high static compression ratios paired with high turbocharger boost pressures. When you pour low-octane 87 fuel into the tank, that fuel is far more prone to premature detonation or engine knock under load. The engine's acoustic knock sensors instantly detect micro-detonation events before you ever hear them with your ears. To protect the engine, the Toyota ECM instantly retards ignition timing. Retarding ignition timing means the spark plug fires later in the compression stroke. This eliminates the knock, but it drastically reduces thermal efficiency and mechanical power output. Because the engine is now making significantly less horsepower and torque on retarded timing, what do you do as the driver? You naturally push the pedal deeper to get the vehicle up to highway speed or pull a hill. Pushing the pedal deeper commands the ECM to open the throttle wider and pump dramatically more fuel into the combustion chamber. Independent dyno and road testing on Toyota turbocharged powertrains demonstrates that running 91 or 93 octane premium fuel allows the ECM to advance ignition timing to its optimal performance curve. Real-world highway testing shows a gain of 1.5 to 2.5 miles per gallon when running higher octane in these forced induction engines under matched driving conditions. Do the simple math for your commute. If premium fuel costs slightly more per tank but yields 2 extra miles per gallon across a 25-gallon Tundra or Tacoma tank, your cost per mile actually decreases on premium fuel because the engine is operating at its maximum thermodynamic efficiency peak. Stop crippling your engine's timing curve with cheap fuel and let the computer run the timing it was designed to deliver. Take 20 minutes this coming weekend and walk out to your driveway with this video. Go through these settings on your Toyota. Not all 10 will apply to every single model year, but I guarantee at least 4 or 5 of them apply directly to the vehicle sitting in your driveway right now. Make the menu adjustments, pump your tires up to the door jam spec, fill your tank, and track your calculated miles per gallon over the next 2 fill-ups. Toyota owners who systematically go through these steps consistently report total fuel economy gains ranging from 2 to 4 miles per gallon. On a truck or SUV that costs $70 to $90 to fill up every week, that is real money back in your bank account every month. If this breakdown helped you understand your vehicle better, smash that subscribe button and hit the notification bell. I am constantly dropping practical automotive content and mechanical breakdowns that dealership service departments would prefer you never see. I'm out for today. I'll see you in the very next video.